Well, good morning, everybody, and welcome back to the Real Estate Show. I'm Alice Lema. I'm a broker here in Southern Oregon with John L. Scott Real Estate. And I'm so excited to have an amazing person on the show today for 3D printer technology to build houses. Who doesn't want to hear about that? We're so lucky to be joined today by Jim Ritter. He is the founder and CEO of Printed Farms. And what they do is they help people do construction with the 3D printers to make houses, to make garages, to make apartments, to make sheds. It's super cool. He's going to talk to us about the different kinds of materials they use, some of the climate considerations, the technology in general, 3D printed houses. Just fascinated by all this. And it could help with the housing shortage here in Southern Oregon. We still, have a little bit of a crunch, even though the market is changing. We seem to be getting more listings on the market. They're getting scooped up, at least the ones that are priced right and are ready to show and easy to show. Those homes are getting scooped up pretty quickly. Having said that, we don't have as many multi-offer situations as we used to, but we still have some. So this is what a mixed market, transition market kind of looks like. And then to top it all off, the feds actually did it. This week, they actually did pull the trigger and gave us that 1/4 point interest rate increase. So a lot of us were aware that that was likely to happen, might happen. So not too much brouhaha about that Federal Reserve Bank interest rate increase this week. I guess they felt like it was necessary. The hyperinflation is just so bad. They needed to do something was what all the announcements were saying. So now we're looking into the future to try to guess, is the Federal Reserve Bank going to do it again? They were talking about doing quite a few increases in a short period of time to help with the inflation problem, but stay tuned. We'll just have to see what they decide to do. In the meantime, we're going to take a quick break from a word from our sponsors and then get on with our 3D printer technology interview with Jim Ritter, the founder and CEO of Printed Farms, talking about how to do construction with a 3D printer. This is so exciting. Gosh, I hope that at the end of all that, we get to find out how to buy one. That would be super cool, wouldn't it? So in the meantime, let's take a quick minute and say thank you to our wonderful sponsors who help us bring this show to the air every week. We've got John L. Scott, Ashland, Medford, Guy Giles, Mutual of Omaha Mortgage, and our wonderful local Rogue Valley Association of Realtors. We'll be right back. Well, good morning again, Southern Oregon, and welcome back to the Real Estate Show. I'm Alice Lema. I'm a broker here at John L. Scott Real Estate in beautiful Southern Oregon, and I'm so excited to bring to you Jim Ritter. He's the founder of Printed Farms in Wellington, Florida, Palm Beach County, and he's going to bring us up to speed on the new technology, 3D printing, creating more housing. Jim, thank you so much for being on the show today.
It's a pleasure.
So just to kind of get started, because in Southern Oregon, we don't have this technology yet. Can you maybe give our listeners just a little thumbnail about what it is that we're doing with this alternative building?
What we're doing with it is we're taking the trades that we're losing through an aging out process, and the machine does what the trade used to do. It squares and sets up the building. And the machine also puts down by layers, better material. So we're actually a stronger, better material building than stick building, which is wood or block. So you have to equate us to a solid concrete structure.
Wow. So there's so many questions. Like, what is this material that you're talking about?
It's a specialized concrete mix because it has to set up within a certain time to support the layers that come on top of it. And so because we don't use forms or we are the forms on the project, the material is a complex cement mixture, but usually has a higher cement ratio than the normal ready mix. So we'll have up to 10,000 PSI whereas a ready mix will be 2,500 PSI.
Wow, that's huge. And so now in Florida, how did you get started doing this? Was it because of the hurricanes?
Primarily because of the loss of trades and the quality of the trades to put up block buildings. I was doing some small developing of horse farms. This area is famous for horse farms. And to get the quality builders was impossible. And it's a shortage that everybody has experienced. And so I looked around for alternative ways to build. And this is what was on the horizon. So I decided to jump in.
And so just so our listening audience understands, we're talking about creating buildings out of a concrete type mixture that's in a soft form like ready mix, and that's poured on the ground and stacked on, the layers are stacked on top of each other vertically. Is that how you'd say it?
No, what we do is we take a dry mix in a silo, and then we put it through a mixer pump system. Then we pump that material into the head of the printer, just like the printer in your house, the copy machine. And like your copy machine, the ink is very expensive. So the printer is one cost, but the ink right now is not scaled up. So there's different inks, as we call it, or print material that we're testing for large concrete companies, plus some materials that we're using. And that material comes to the head of the printer, just like you do in your house. And layer by layer, it makes sure, like any 3D printer, it builds the shell of the house. We only do the shell of the house, or print the forms for the beams or the slab, or the form for the beams of the roof or something like that. So we don't, this idea that we print the whole house is not valid. We print about 35% of the house, but while we're printing, we incorporate a lot of things where we add in the insulation, the boxes for the electrical, the conduit for the electrical, the rough plumbing. This way, you're not waiting on trades, which is also a big cost if you have a lot of downtime. So as we're printing, when we're done, if everything is organized and you put your windows and doors in, you have a closed system that can be finished by the general contractor inside and outside, because everything is incorporated, what we call a closed shell system.
Well, that is just amazing. It's just amazing that you can do that. And so 3D printing of a house, what kind of size dwellings are we talking about being able to create?
Right now, our machine can do about 1,600 square feet, 2 stories. So total, we would say.
Wow, you can do 2 stories.
Yeah, we can do 2.5, but we stick to 2. We do have, of course, in South Florida, high wind velocities from hurricanes, and Miami-Dade is one of the toughest code systems in America. So there's some technical issues as we go up on walls that are 15, 20 feet high, single stories, but we can print up to about 30 feet.
Wow.
And we push people putting flat roofs on, that we pour the concrete with the machine. And by doing this, we take a lot of people off the second story and those floors. So the accident ratio is much lower because there's no one there.
Yeah. Wow. So it's safer. That is so interesting. So with the labor shortage, you were talking about, that's how you kind of got into that too. And we just had huge fires here in Southern Oregon, and we lost 2,500 homes in just a week. And we're still trying to recover from that. And the trades are stretched thin. And then this was after the pandemic. So when you brought this into your county and started doing it, you were doing it to replace labor, but the labor that was already there, did you get any pushback, or did you get any attitude from people?
No, because we're not big enough to impact. There's so much. Florida is one of the fastest growing states in America. In fact, in January, 50% of the jobs came through Florida for the United States, because we have such a boom. We're in a huge real estate boom in South Florida. So everybody is so busy, no one really cares. We're trying to build better buildings. We also just lost 1,100 houses in the north of Florida, the Panhandle area, due to forest fires. So that is what we're trying to do, is build greener, better buildings that will survive these catastrophic events, which we know are happening due to climate change. In Florida, of course, flooding is huge. They're building seawalls because if we don't, we're not going to be here. Hurricanes are more intense as they see. And then, of course, we have the forest fires like you have. And concrete homes right now are the best way we have to build habitats that will survive these catastrophic events. And 3D printing makes that cost effective. And so we're not cheaper, we're not, we're not always faster. It depends on the project, but we are much superior in materials and quality of building. And I think that's very important for people who've lost a home. They can't just keep going to their insurance company because they get dropped.
Right.
They dropped 50,000 people in Florida alone.
Oh my goodness.
On insurance because of the worry about costs. So all these factors come into play and why 3D printing will be better in the future.
Wow. Wow. So when you're putting the closed system together, you were talking about electrical, plumbing. What about heating and cooling? How is that incorporated?
That's incorporated in a conventional way. We don't do the ceiling. So your MEP system, if your readers, if the listeners don't know, MEP is mechanical, electrical, plumbing. So we leave the ceilings open, and of course your air conditioning down here where we are would go through there, or your heating ducts. Your plumbing is conventional. It's just because the machine is doing most of the work, we have a crew of about 4 people, and they set the ladders in the walls, they set the boxes in the walls. And so the next day, and when we get to a certain point, we run the conduit. It's just easier and faster and cheaper. That's how we save the builder money.
Wow. Wow. That's just incredible. And then it's more earth friendly and more disaster proof.
Well, if your concrete companies and some of the ones we're dealing with produce carbon-free concrete by burning waste or whatever they do, then concrete buildings are carbon sinks, and they absorb carbon for the rest of their life. So they are very green. Obviously, because we have a denser material and an airspace, we're a better building for insulation. We're tighter than block as far as water seepage or permeability to water. This is very big when it comes to rebar rusting in buildings, because that's a huge problem in Florida. If you saw the disaster in Sunrise, and we feel by printing this envelope in the building and putting the rebar in the middle, we mitigate that problem, because
wow,
the rusting comes from the salt air coming in through the building.
Mm-hmm. Very well thought out. And so when the consumer goes inside of a house, is there drywall? Do you have the rough leftover of the concrete? What does that look like?
We try to take drywall out of the condition. I'm an anti-drywall freak. I hate it. And so what we do is we print the interior and the exterior walls. So we don't have studs to carry sound. The walls are stronger. I believe in the old plaster methods, plaster your interior walls. You can leave your walls rough, but as my wife says, who wants to clean it? So I like
it has like little
smooth,
grooves in it.
yeah. So I like a smooth finish, but that's up to the individual. But we print the interior walls, and the way we do the doorways and everything, it gives a very inviting way to put in good walls, have a very soundproof house or sound resistant house throughout. It's a much stronger, nicer feeling.
Yeah, I was thinking, and when you said denser than the old school plaster, those houses were somewhat soundproof, tap down the sound, and their insulation value was quite high. So what are we talking about in that department for these 3D printed homes?
We don't have all the data, but the buildings we've done without insulation, we feel we have a 12 R12 with just the dead airspace again, because you don't have that movement of air through
Right.
there. But with insulation, we could easily get 20-25% for the walls, and of course the roofs you would do standard for your area,
So when
depending
you
on your climate.
so are you putting insulation in the ceiling then? Is that what you're talking about?
And I mean, we used an ICF system on one of our sheds. So
Oh,
that has a standard, that's insulated concrete forms. And that has a standard R value, I want to guess around 25. That's the roof for the shed we did on one agricultural shed.
wow. Well, super cool. Folks, you want to stay tuned. We do have to take a quick break. We get a word from our sponsors. We're having the most amazing conversation, 3D printing of houses, sheds, and buildings. Jim Ritter, the founder and CEO of Printed Farms of Wellington, Florida. I'm Alice Lema, your host for today. We're brought to you by Mutual of Omaha, Guy Giles, the lender in-house. We have John L. Scott, Medford and Ashland, and also our local Rogue Valley Association of Realtors. Do not touch that dial. Jim Ritter, the founder of Printed Farms 3D House Building. We'll be right back. Well, welcome back, everybody, to the Real Estate Show. I'm Alice Lema, broker John L. Scott here in Southern Oregon. And today we're talking to Jim Ritter, the founder of Printed Farms 3D Construction. He's out of Wellington, Florida. And boy, what an eye-opening conversation this is, Jim. I cannot thank you enough for being on the show today.
Thank you.
So not only did I learn already about how green friendly this construction is, but it's really cost appropriate compared to what you would pay to have is that what you call it, conventional construction done?
Well, it's a superior building. You can only compare it to another concrete building. And for very large buildings, we are working on some tilt wall systems with the 3D printer that we could incorporate the two, because making the forms for tilt wall is very expensive, but because of our freedom of design, it's very inexpensive for a 3D printer. So we're exploring that route for very large buildings. But for your standard home, which is about 2,000 square feet, we 3D print it. The only problem is we don't have that many printers out there. We don't have a lot of builders doing it. And we're still learning the process to print quickly and effectively and cost effectively, I mean, to make it more commercially viable. So right now, because the machines are custom made, the print material is made in small batches, we're not scaled up. So we haven't met our price thresholds that a lot of people are alluding to in their videos and everything else. We're not there yet, but it's coming. And because, like any other industry, whether it's the auto industry or any industry, these are just large robots who do the job, and they're a tool. That's all they are. They're, really, we're building conventional using this tool and using a new material. Other than that, it's all the same. But it produces, in our mind, a much better house for the future.
Well, and the idea that some of the ingredients in concrete absorbs carbon, that is an amazing thing in this day of climate change.
Well, we currently in our building, we use no wood. Even the bucks for the windows, if your permitting allows you to TAPCON right into the cement for the windows, that's the best. But if they require a buck, we use hardy board, which is a cement product. So when we're done with a house, there is no wood in the house, and wood doesn't go well with South Florida. I don't know Oregon's climate or building, but for Florida, it's a very salt, humid environment, and wood just rots. It doesn't matter what you have. So we take wood out of the equation, and by building these cement homes, we really feel they're a superior building.
So, and if you're going to spend the same amount of money approximately, and you can have this superior building, I just think it's a no-brainer that this is where people are going to go. And then you don't have to have as many work people. You don't have to have as big of a crew, and you don't have to have the delays. Because that's part of what we're struggling with. And you said you had fires in northern Florida, so you know what this is like. You just can't get anybody to do anything on time, much less at all. We just don't have the bodies. So this would replace some percentage of the labor force. It already is.
Well, and it, that is all very true, but you do have to bring it up to scale and scale it up and bring it in to the mainstream by training people. You still got to train this crew of 4 that interact with the machine and do everything. And that's what we're doing. We're working with the US Air Force, took a machine, and we're helping them.
Oh,
And so we
awesome.
train everybody, they get the machine, we train them, we give them the knowledge we have about building, we tell them how we got it through permitting. And by doing these steps, yes, you end up with a better building. And all the Printed Farms did is we took the machine and said, okay, what can the machine do today? Not what it can do in the future. And today it pretty much prints the walls and pours. We can pour the slabs and that. And in any concrete building, you have 3 to 4 different concretes that go into that building.
Oh, really?
Your slab material, your beam material, your roofing material, if you have a lightweight cement roof system. So it's not one material. The machine has to interact with several different materials and utilize those materials to the best ability. And that's what we've been doing a lot in Printed Farms.
So do you if somebody's buying, let's say I was going to buy one from you, which I might. So if someone's going to buy one from you, do I bring my own 4-person crew and we go to Florida and get trained?
Yeah, we would prefer that you would that we would train your crew. I mean, it all depends on obviously the contract, but it's not that difficult. I mean, we did a 2-week course with the Air Force, and they're printing their 2nd building.
Are they really?
Yeah, they also were hit by a Hurricane Michael, Tyndall Air Force, and they lost a lot of buildings. So they're going to do a lot of barracks and things like that. But the bottom line with it is, it's not, yes, the machine is complicated like your car today, but to learn to run it is not that complicated. And I have no background in 3D printing. When I got out of high school, we were still doing keyhole punching. So that's
Me too.
So you don't have to be a rocket scientist to run these systems, but it does help actually to understand the materials and be very good with concrete, because it is still concrete, and concrete is one of the more finicky building materials. And unlike pre-made materials that come to you like lintels and block and everything, you're manufacturing on the spot. So weather and everything else can influence
like temperature and humidity and wind.
Correct.
And all that. Interesting. So would it behoove me or some other person who wants to buy one of these machines to bring the 4-person crew and have them already with a background in concrete? Is that kind of who you would want me to put together?
I think one person would be good to
At least
understand concrete and how it works. Basically you need some real building people on the job, because we still use ladders for building the walls to keep the stiffness to the walls as it sets, like conventional building. You still got to set your boxes and everything. So there is a lot of conventional building that goes on. You still have some shoring depending on your roof system or the size of your door opening. We've gone as wide as 9 feet for a door opening. So that
wow,
supported while we poured the beam, just like conventional. Having people who have done building and understand it, but then you need that person who likes to play with CAD, which is the system usually used, and understands the laptop and all the programming, so they can on the fly, fix and adjust anything the machine might need. So, we like to get a kid who's really into that 3D printing, has a 3D printer at home. That's always great because they run the laptop and they're really into that. And then I bring the building crew.
Okay, so it is a team. You're putting together a team,
It's
and then they're getting
definitely a
trained.
team that has to work together and sync together because as one GC said, I never had to go so fast because now you got to keep up with the machine. And the machine is going and you got to lay this stuff in and down and you got to be ready for it. You can't just be sitting around and go, oh, I forgot, which they did in the doorways. And we do certain things in the doorway so that the doors you order fit. And they
Yeah, I
didn't
was going
do
to ask
that.
about that.
Well, we block it out. So make sure that it measures because you do have some over extrusion of the material. And even though it's programmed correctly and it's doing the right thing, you could get more material in that opening.
Oh,
That it's
okay.
not a 3.5 foot opening or 40-inch opening. Now it's a 38-inch opening and you order doors for 40-inch opening.
Of
So,
course.
so we have a system for that also. And we don't use pre-manufactured lintels. We make them on the spot. So there's a lot of stuff that we've incorporated that we help people with and just saves you making our mistakes.
Yeah. So you're putting in traditional doors, traditional interior doors, traditional
Yes.
interior windows.
Interior, exterior. One of the beauties of 3D printing is we have rounded corners. So on exterior doors, instead of having to set them out towards the outside so that they can swing open, we can set them in the center and they still have more swing than you would on a conventional
Oh,
building.
wow.
Square corners.
That's
So,
cool.
yeah, there's a lot of cool things that come out of printing that I would call serendipity or luck that we didn't know about, but just by the nature of the printer that we feel is a nicer building.
Yeah. So one of the popular interior design elements right now are those giant, they're sliding doors, but they go into pockets. You see them a lot in Southern California. Maybe you have them in Florida. They're super
Yeah, we
popular on the
do.
beaches.
In fact, we have designed a 4,500 square foot house on the intercoastal on some property we have, and we haven't started printing yet, but that's in that design. That's no problem.
So that's
just
no problem.
No, that's
Wow.
just a beam design, and then you just print your walls on either side for the width. I think ours is 18 inches. I forget because you get multiple doors. We have 5 doors that slide in there.
Right.
Oh yeah, I think it's 2 feet. So we have a 2 foot, area where those doors slide into.
Mm-hmm.
And then,
Mm-hmm.
so we have that designs that we've been working on. And of course, because we have 15-foot high ceilings in there, we have quite a wall design that we're doing the engineering. You do need structural engineers in that because we don't have the library of engineering for 3D printing that we have for conventional.
Gotcha. So who brings that expertise?
Structural engineers, you go to.
Oh, you just get a regular structural engineer. Okay.
Yeah, they're savvy, and we have some ideas that we give people how to get it through permitting and that. And just like when they started block, I mean, when they started block, they didn't build all block buildings. They basically built post and beam buildings. So we initiated a lot of these methods so that if you do, what we could do is solid printed walls. If you do that right now, the code hasn't caught up to us. So
I was going to ask you about that. Yeah. How do you deal with the building department?
they're no problem. We just got a building with Miami-Dade, electrical building for a large concrete company that we told them how to do it, and Miami-Dade said yes. And so now they're going into the the permitting process.
Wow. So
So
they're approving a 3D building just
yeah,
kind of as part of the normal course of the day.
yeah, because of the way we've incorporated conventional with 3D printing. And as 3D printing takes a larger and larger hold, of course, there's going to be certain aspects of 3D printing that are totally different than conventional, but accepted because there's enough buildings. There's no 10-year-old 3D printed building out there in the world.
I wonder, what is the oldest, do you think?
I think 3 years, 4 years.
3 years. Wow. That's super young.
Yep, that's the problem. We're still in our infancy and we're not there yet, but it's it's growing in leaps and bounds, and we're going to be there soon.
Yeah. So how long does it take to build a 2,000 square foot house? Let's say flat
We printed
property.
the exterior, interior walls in Tallahassee in 6 days.
6 days to 3D print a 2,000 square foot house.
Well, no, we did. It was 1,530 square feet. So we printed that in 6 days, the interior and exterior walls. And that was the beam was 9 feet ceilings.
Wow. So many questions when we talk about floor plans and insurance. And are you just uploading a digital floor plan? Is that how you get the interior walls?
No, we leave that to the individual. They design their houses and we print what they want, because the great thing with the printer is we can print a circular room. We can print, we have freedom of design. One thing that we can do that conventionally would be very expensive, and we have it in one of our designs, is a curved beam, because we print the form for the beam, and then all you have to do is pour it. To do that conventionally is a lot of woodwork.
Yeah.
And very expensive. So,
and that's if it's done right.
Yeah, we see 3D printing for luxury houses as very economical right now.
Yeah. Well, we've got to take a quick break. Sorry to interrupt. 3D printing, Jim Ritter, founder of Printed Farms. We'll be right back after a word from our sponsors. Well, hello again, folks. Alice Lema, broker John L. Scott. Welcome back to the Real Estate Show. We're talking to Jim Ritter of Printed Farms out of Wellington, Florida. And during the break, Jim, we were talking a little bit about what it was like when you guys came on the scene and the splash you made with the other 3D companies.
Well, what we did is our intention when we got number 5 machine produced by Kobo. And we've done several things to further the 3D printing industry. One of the things we've done is never bring the machine inside. We've left it outside for 2 years.
Wow.
Because if it's a building machine and going to do what everybody claims, it has to work 24/7 in all weather. And we did that. And so far, the machine's been very good. But that's only 2 years. And hopefully I can say this after 5 years. So the machine has to take the weather. We were the first people to print outside of a tent or building. We said that's not economical, so we printed totally outside. And of course had our issues to figure that out. And the other thing we did is we utilized the machine for what it could do to build a building, and we incorporated the conventional methods that would be approved by the permitting agencies into our building design, so that the 3D printer could be used to its fullest, which is pouring the slab. We were one of the first people to take the machine and pour the foundation or slab so it was square and everything. By printing the form, we had this being square and level. Then we poured with the machine. Then we, of course, printed the walls, which everybody does. And we printed the cavities for the columns, and which support the roof. And then we use the machine to pour an ICF system roof, which is a standard conventional system. And we use that system, what we call prints, and it came out very well. We didn't know it would, but it did. And, you know, we put in the window and the doors and the lintels. We printed the forms for the lintels. We printed one of the first tie beams. Our tie beams almost 36 inches or 3 feet high. The building's a bunker, to put it mildly. So it is overbuilt, but we were testing a lot of different concepts. And we didn't publish it until we were done. We said, okay, now we can publish. Now we can help people to build in a more effective way. And that's how we got into the Tallahassee project, because we had one of the most economical, effective ways to print a building. And in Tallahassee, it rained all week and we still got it done.
Wow.
So it was a mess, but you know, we got it done.
Well, that's construction, right?
Right.
Construction is messy. Super cool.
So it's using these machines in an economical way is what has to be done so that we get a greater data and everything else. So
So you're creating the machines
No,
and
Kobo, we're a distributor for Kobo.
distributed for Kobo. And where do you get the material for the print job?
Well, right now we're dealing with several providers, Latticrete, Titan, CMEX, Argos, and we have a local outfit in Orlando that is very creative, that we're testing their system, their material. And we do a lot of material testing to improve the material so we can print faster and higher. When we started printing, we printed at 3/4 of an inch. Now we're almost up to 1.5 inches, which cut our print time in half.
Wow.
So we trying to build thicker layers, but not wider. There's a 2-to-1 ratio, and we're trying to shave that. You have flaps where we can print with a smooth finish. And so we do a lot of testing. We testing the materials so that when we sell it to people, it does what we say it will. And it's the right material for the building. And of course, the same for the machines. We work with the machines. We do our test projects in real project time so that we know what the problems are with the machine. And of course, we fix it with the manufacturer so that the machines work better and more effectively.
So we were talking earlier about different climates. So Southern Oregon is a drier climate. How do these homes withstand less moisture, a lot more heat?
Well, that's no problem. They printed in Arizona, which is very dry, as you know.
Yeah.
So Perry, which is also using the Kobo system, they printed some Habitat for Humanity houses there. It's your curing process. The drier the area, you're going to have to put a lot more water as you print on the project and keep it moist. Cover it and keep it wet like you would any slab or anything. We in the summer are very humid, a lot of rain. So of course, with our Tallahassee project, that wasn't an issue because we had too much water as it is. But that's part of cement. You want to cure with a lot of water because you don't want the wetter interior to be drying at a different rate than the exterior. So when you have two different rates of drying, and this is any cement, that's when you'll get cracking. So we tried, that's with 3D printing the same. So you would have to have a lot of different systems for keeping the material moist until it cures, which usually.
And then snow country, same thing.
Well, the Germans printed in a sleet storm, which was about 3 to 4 degrees centigrade. I am in Florida because I've been in Sweden and North America and I hate it. So you can have the snow. I think cold is the biggest challenge to printing. I mean, you obviously, and then again, it's a cement thing. It's not a print thing. You have to be careful of freezing and everything else. So you have to mitigate, at what temperature you can print in. Whereas we have the opposite problem where it's very, very hot here, 94 degrees in the middle, normal, during the summer, and the hoses get very hot. So the material has to be able to take that heat. So every area of cement is tweaked for that climate locally. So it's a localized system, the printer, the material, and everything else. You can't do what we do here in Oregon. We'd have to change it. We'd have to tweak it.
Well, but the beauty is you can.
Yeah, well, that's, and anybody who's dealt with any cement understands this. This is why you would like cement people around you, because they understand what cement works in your climate, what chemicals, what you need to do.
Oh, this is just so exciting. And we have a housing shortage here, as you guys do too, for a lot of reasons. And this is something that a lot of us small developers, small builders are thinking of bringing on to create housing and also just have more green construction, because that's important too.
And again, a concrete structure, something that we push down here, especially if you're in a dense area. You have the rooftops that you can utilize for solar panels, but also for a living space. And they're concrete. I mean, you want to put your spa up there, you can design it, set your spa up
that's
there.
a great idea.
And you see it in the Mediterranean. Again, we didn't invent this, but rooftop gardens are beautiful. You have a better view. then, and it's so much nicer than a cramped backyard where a lot of people, they see a 6-foot wooden fence.
Yeah.
So we promote a lot of things. There's a lot of things that you can do, by doing concrete structures that just make a better living area.
Well, we're talking to Jim Ritter of Printed Farms in Wellington, Florida. He's the founder and CEO. So Jim, just real quick, how can people get a hold of you?
Well, they can go to our website at printedfarms.com, and there's our phone number and info@printedfarms.com. You send us a mail and we answer it to our best of our ability, and we go from there.
Well, thank you so much, Jim. I hope you'll come back and give us an update later in the year.
All right. Thank you very much for having us.
Have a good day, Southern Oregon. See you next week. Bye now.